Okay, so this is section 8.1, day 2. We have properties of integer addition to review. These should be reviewed because we've done them before with fractions and decimals. But we know that if we have any three integers, we're calling them A, B, and C. The closure property for integer addition says that if you add A and B, or any two integers, you will also get an integer. Commutative property says that if you're adding two integers, you can add them in the opposite order. Associative says that if you're adding two integers and the parentheses say to add the first two and then the third, the associative property says you could change that and add the last two. And so take the first and add on the last two added together. So the order of how you're adding is changing in the sense of which two you're adding there. The identity property for integer addition says that there is a number called 0 that is a unique number such that when you add it to any integer in either order, you will always end up with, this should be A. You will always end up with A, not 0. If you add A plus 0 and 0 plus A, you get A. That's identity. And the additive inverse property for integer addition says that for every A, so every integer, there's a unique opposite of A, such that when A and opposite of A are added together, you get 0. Opposite of A is also called the additive inverse of A. It is not necessarily negative, because if A itself is -7, then the opposite of A is the opposite of -7, and it is +7. So when you see negative A like this, you don't want to read it as negative A. You want to read it as the opposite of A. We have a theorem that the book calls the additive cancellation for integers. I don't like to call it that because I don't like to use the word cancel when I teach math. So I'm going to call it the additive inverse for integers. And it says that if A plus C is equal to B plus C, then A equals B. And what you're doing to go from the first statement to the second statement is you are acting as if this is a balance, your equal sign is a balance, and you are subtracting C from both sides of the equation. And if you subtract the same thing from both sides of the equation, you still should be in balance, and A should equal B. And that is a property that we use when we're solving algebraic equations. And then finally, the last theorem we have is that the opposite of A is A. So the question then is, well, is A positive or negative? And the answer is, I don't know. I don't know what A is. But if A were 6, if that's what A were, then you would say the opposite of 6 is +6. So A could be -6, and then the opposite of 6 would be -6. So whatever way A starts out, the opposite of it is A again. And so those are theorems and properties that we're going to use in our discussion about adding and subtracting. So for example, the additive inverse of -7 is +7. And the opposite of 2 plus the opposite of 2. Well, the opposite of 2 is 2, because that's the theorem we have. And when we add 2 and -2, we get 0, because that's the inverse property. Okay, moving on. Subtraction. We want to think about subtraction in a lot of different ways. And one of the ways is a pattern. So if you were teaching your students subtracting 4 minus 2 gives you 2, then they could think about it, what would happen if you took 1 less away from 4. So 4 minus 1, well, then that should give you 3. Because when you take 1 less away, you should end up with 1 more than you did before. And if you follow that pattern, they could see that 4 minus 0 then should be 4. And then they could start to think about why 4 minus -1 is 5. So by following a pattern, some students it'd be easier to convince them that 4 minus -1 truly is 5. Because then you're subtracting 1 less than when you subtract 0, your answer should be 1 more. So students who struggle with, wait, I'm subtracting, why is my number getting bigger, could start to see why when you subtract a negative number, your answer would get larger. So one way to think about it is with a pattern. The other way to think about it is a takeaway method. So if you want to think of subtraction as takeaway, an example of how you would do 6 minus 2 when the numbers have the same sign, we're going to use those stars and those hearts that we used last time to explain that if you had 6 stars, and stars are representing positive chips and hearts are representing negative, you could take 2 of your positive stars away and you'd be left with 4. And if your stars were, or if your chips were hearts, so they were negative values, you had -4 and you wanted to take away -1, it would be the same process. You'd take away 1 of your hearts and you'd be left with 3 hearts, which is -3. So it's fairly straightforward when they have the same sign. But what if they don't? What if you're trying to take away 5 from +2? So here's the idea. If you want to take away 5 from +2 so that you have, I'm sorry, they still have the same sign, but this one is larger than that one. That's what I'm trying to say. Sorry about that confusion. When you're trying to take away more stars than you actually have, we have to do a rewrite. And this rewrite can get a little tricky, but you'll get the hang of it as you practice it. I have 2 stars and I'm trying to take away 5. So what I do is I make sure that I have 5 stars. So I put another 3 stars in my circle. Well, now I've just changed what I was starting with. And you're not allowed to change the question. So these 3 stars that I put in get matched with 3 hearts. So the 3 stars and the 3 hearts together, they're inverses of each other. So if you look at all of that, it's really just the number 0. I really only have 2 stars. But I'm rewriting it in a way that I'll have the number of stars that I need to take away. And once I take away those 5 stars, I'll be left with 3 hearts, and I can see the answer is -3. So 2 minus 5 is -3. Creating the stars you need to take away by putting the hearts in there as well is one way that some students will be able to see why the answer is -3. Moving on now to the opposite signs. So what do we do if we have -2 and we're trying to take away -3? So we want to rewrite this so that we have 3 hearts to take away. So we add an extra heart and we pay the price for that heart we put in there with a star. So the heart and the star are 0 again. What's in this circle is equivalent to what's in that circle. But we can take away 3 of the hearts. And when we go to take away 3 of the hearts, we're left with the 1 star, which is why we can say that 2 minus -3 is 1. So using takeaway method, you want to take away. If you don't have what you need to take away, you have to create it. You have to rewrite the problem so that you can. You can relate this to trying to subtract a 9 from a 0. You don't have enough to take away and remain positive. So we borrowed, if you remember, we borrow 1 from here and turn that into 10 so we can take it away. It's the same idea, is we don't have enough hearts, so we have to create those. Sort of by borrowing a heart and paying the price with a star. Instead of borrowing a 10 and changing the number of tens that you have. So it's along those same lines that you want to think about. The final way, and this is the way my brain does it, is adding the opposite. I never subtract, I always add the opposite. So if I'm looking at a problem that says A minus B, I'll say, I'm going to make it A plus the opposite of B. And that way I can use all the rules that we learned last time, just addition. I'm never subtracting, I'm always adding. And if I had the problem 2 minus 5, I would see it as 2 plus negative 5. And I would have 2 stars and 5 hearts. And as I added them up, this star and that heart would go to 0, this star and that heart would go to 0, and I'd be left with 3 hearts, which I know is negative 3. So all the rules that we had last time for adding would apply if you can change it to adding the opposite. And the final method is the missing addend. This one is a little bit more creative if you have people in your class that are creative thinkers. It goes like this. A minus B is C if and only if A equals B plus C. So in other words, 2 numbers are going to subtract to be this value of C only if the first number is C more than the second number. And for example, you would say 5 minus 2 is what? Well, 5 minus 2 has to be the number that, I got to think backward on this one. Okay, 5 minus 2 is what? Means that 5 is 2 more than this what that I'm trying to figure out. 5 is going to be 2 more than the number I don't know, and then I could say, oh, well then that number I don't know must be 3. If 5 minus 2 needs an answer, then I have to ask myself, what number do I add 2 to get 5? And the answer is 3. And for the last one, negative 12 minus 5 is what? I'm trying to find out what number, when I take it away from when I take 5 away from negative 12, what number do I end up with? So the answer to the question is, what number do I add 5 to get negative 12? And then I can think, oh, I add negative 17. Negative 17 plus 5 is 12, so that's the answer. So again, that's a little bit convoluted, but it might reach some students where other methods would not. And you have some examples to do at the bottom to try and see if you can use multiple methods. Don't always use the same method. And I will see you next week.